Start the tape.
I didn't know what I was doing over here.
I believe you're there.
Okay.
Have a good
So we should be turning in 2 graphs tomorrow, one for the procedure A and one for the procedure B.
Yes.
Okay, cool.
Other questions? Robin?
Can you go over how to graph the position of the body image
Turn in 2 graphs,
acceleration?
one for procedure A and one for procedure B.
All right. Is it not lateral weight? Oh, what, no, it is lateral weight.
Yeah.
All right, so if you recall, velocity is the change in position over the change in time. So if I have a position time graph, the slope is velocity. So rise over run. If acceleration is the change in velocity over the change in time. So if I have a velocity time graph, that doesn't defy what we know of life, slope is acceleration. So once you recognize the slope, then it's a question of how do you find slope. Well, I know that the slope of a straight line is constant. So if this is position time, I know the slope is negative, and I know that it's constant. So my velocity time graph is going to be a negative value and constant. Now the slope of this is going to be acceleration, and the slope of that is 0. So those would be 3 graphs that would go together. We could keep going actually. I talked about jerking here, right?
Yeah.
Yeah. So my jerk graph, well, is the slope of this. So that would also be a flat line. So from acceleration on downwards, they'd all be flat. Another way of looking at this, and for those who have had calculus, this will be hopefully second nature to you. But this is a straight line, so this is a time to the first power. It's a first order polynomial. This one would be t to the 0 power, and this would be, well, once you get to here, this would be 0. So if I start out with a position time graph that is parabolic, in other words, times some function of time squared, my velocity time graph, from the slope point of view, it starts out low, starts out at 0, and then steadily gets bigger and bigger. That would be a straight line. So that's a function. So that's a function of time squared. That's a function of time. Acceleration, well, that's a constant slope. It's positive. That's a t to the first, t to the 0. And you can keep going. If I start out with a t to the 4th power function, then I'd end up with a t cubed, then a t squared, t to the 0, 0.
How would you so like let's say in your position, there's like a lot of curving. So like it rises, plateaus, rises, plateau way.
Right. So if you're dealing with a curve, well, let's do something fancier than a parabola. So let's say that is a position versus time graph. If I want to figure out the velocity time and it's curved, well, the slope is the slope of the tangent line. So here, my slope is negative. There, my slope is positive, negative, positive, negative. So the easiest way of doing it, if I have a complex curve like that, is to first figure out where it's 0. Where is the velocity equal to 0?
When it peaks at the top or in the bottom of the graph.
Yeah, at the peaks and troughs. So here, 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 Another way of looking at it is this is a one-dimensional problem. We have an object that is moving up in the positive and negative direction. This is the point, they're getting farther away from the origin. At that point, they then start moving closer. So this is a turnaround point. So you have to stop to turn around. So you stop, come back, stop, stop, and keep oscillating back and forth. I know it's positive here. In this region right here, my slope. And I know it has to hit those 2 points. And then positive, negative, positive. Something like that. It's a crude sketch. And then acceleration, I would go through the exact same process. I'd first identify the zeros. There, 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 there. And then go through and, so in this region right here, my slope is positive, negative, or zero. Negative. And we basically lose a hump every time. Although, you can make it more complicated, but that's the essence of it.
How about if you're going from acceleration to how about if you're like going from acceleration to position? How would you do that part?
All right, if you're going in the other directions, all right, so if I'm going in this direction, I'm taking the slope.
Yeah.
If I'm going in the other direction, and we sort of hinted at that yesterday. Yeah, yesterday. First, I'm gonna do it the complicated way, and then I'll talk about it the simpler way. If I have, let's start out with velocity time, that is straight. If I sort of break that in half, break the time in half, so I've got 2 halves here. I have the area of this trapezoid is more than the area of this triangle. So I know that it travels a greater distance in this time than it does in this time. It's going faster, and if that's the same amount of time there, if it's going faster, it should be traveling a farther distance. So if I were plotting x versus time, then I know at the halfway point I'm some distance, whatever it happens to be, and because I'm gonna run out of room. And then I know that, so I went that far in the first time segment. The second time segment, I'm gonna go farther. And I start out not having gone anywhere. Actually, what I've done is displacement versus time. I don't know what the starting position is if all I have is a velocity time graph. So what it ends up being is that the area under the curve of velocity first time is equal to displacement. Now, if I have a displacement graph, what does my position graph look like? Well, displacement starts at 0. Because when I haven't got, at time is equal to 0, I'm at my starting point. And so whatever my position is, that's how much I shifted. So let's say I have a displacement curve that looks like this. And I need to do a position graph. Well, what was my initial position? Just say my initial position is here. Then what I'm doing is I just shift everything up that much. Questions here?
Similar to not this question. Can you just elaborate a little bit more on like determining instantaneous displacement? Because I understand our displacement, but instantaneous displacement.
First off, questions on the graphs before we talk about instantaneous displacement. All right, so let's say I'm starting here, my starting point, I move out to the right, I move to the left, I move back, and I end up right here. If I look at my displacement, and again, no modifier, so that's overall displacement. My overall displacement is from where I began to where I ended. So that's my overall displacement right there. I went a bunch to the right, a bunch to the left, back to the right. So if I do that divided by the amount of time it took, that's gonna give me average velocity. Now, so I'm looking at where I started the whole journey, where I ended the whole journey, divided by time. If I'm looking at instantaneous, well, let's take a look at this point right here. At this point, so I've gone all the way back, I'm starting to head back to the left. My average velocity at that point is, well, there's my displacement, overall displacement divided by time. Instantaneous, I'm not looking at the whole trip. All I'm doing is looking at where, this is where I'm concerned, where was I just a moment before? And so that would be the displacement, or instantaneous displacement. And so velocity, really by definition, the notation's a little bit off, but would be instantaneous displacement divided by time. That's it. All right. Other questions on this? Other questions?
I just have another question. I think I can't log in right now, I need to try again, but I think the, files under the master set don't let us open them. Like it says you need permission or something to view it.
I didn't accidentally click the need a task code. It didn't prompt me for one, so.
It's not ask for a passcode, it's just,
It's just we don't have access to
Yeah,
it.
That's what it told me.
All right.
I mean, it's fine like that, you can just.
I still expect it to be handed in though.
Oh.
You just have to guess what the questions are.
Make up your
so
own.
we can make up a new question.
But if you don't make up one that I made up, no credit.
Are the homework problems in the textbook, are those just practice, or do we need to be turning those in?
Well, I gave you the answers, so
Right.
they're just practice.
Okay.
In a 8-week course where we have more time, I would do a quiz based on those.
Yeah.
But you'll have fewer quiz grades in an 8-week class. Did I say that right? In a 16-week class.
And those master key, the one that's due tonight, is it not due tonight, or is it due tonight?
No, I have to put a due date in.
Okay, yeah, you
when
told us that yesterday.
Yeah, so it will eventually be written up there of what the actual due date is.
My other question is in one of the modules, like the homeworks, it just like disappeared. Does that make sense? Like it just, on Blackboard, the file for it, it disappeared and it just says not applicable.
Huh.
And it did the same thing for what was the master set one, but I just assumed that means we were
There is
supposed to
no
do
master
that
set one.
But the homeworks from it also just like disappeared.
Wasn't it? All right.
I just wanted to let you know.
So we have an issue with master set 2 doesn't seem to, says you don't have access.
Yeah.
And what disappeared? The homework disappeared?
Wait, those are still there.
No, the homework
Mine
ones are
came
fine.
up saying it wasn't, but that's just my.
All right, and,
Mine shows up just fine. So that's,
okay, that's the homework.
That's.
All right, and go to the master set.
this is the first master's.
Oh, yeah, there's no master set 1. That should leave that.
Master set two though, the files.
You go right here and
Yep.
then,
I think it was
and then it'll appear like this, and you try and download it,
Yeah,
and it
it's
takes you to this page. This one's not trying, you're not permission to access it.
Has anybody found the
Okay.
videos for the graphing, where he shows us how to graph it?
Yeah.
What is it under?
All right, I guess I see you 4 days a week, so just, if it's not available by tomorrow, just let me know again. Yay, new Blackboard Ultra.
I think I like the other
Yeah, well, the one thing that Blackboard Ultra has that the other one did not is drag and drop. If I need to move a file from one place to another, that, I like that. Other than that, I can't find any advantage to it.
Just so many drop downs, it's like organizing your phone. If you drop down this thing, it's just everywhere down.
And you forget where you were.
Yeah.
If I want to delete something, it pops up with, sure you want to delete this, as opposed to, you're about to delete, and it tells me specifically what I'm about to delete. So if I have two things that are named the same thing, or named close, I don't always hit the right button. You know, I could easily hit these three dots instead of these three dots and potentially delete something I didn't want to. That's a me thing though. All right, other questions? Have a go.
You said we could turn on our graphs on Blackboard, that you made like a thing we could turn our graphs in on?
Yes,
Okay, and then we'll write on our paper that we turn them in on Blackboard?
yes, please. And there are online submission guidelines in the syllabus, please read them.
For the,
First, Giovanni?
So I'm checking master set 3 and
Uh-huh.
it's working just fine. It's just master set 2 that's kind of glitching out. Not glitching out, but not really working. Like, I
Okay.
can download material from master set 3 instead and have it for master set 2.
All right, so master set 2, no access, master set 3. Okay, all right, so if nothing else, I can, I guess, copy it, change the name, delete a file, add a file, I don't, we'll find out. Push comes to shove, I'll print it out, hand you out paper copies. All right, anything else? Robert, you were about to ask a question, right?
so for the graphic lab, so for the circumference and diameter, should the diameter be on the bottom and circumference be the y-axis?
Yes,
And then for the other one, distance should be the x-axis, time should be the y-axis?
time squared, distance.
Okay, and then, I just asked this there actually, so this is my question.
Whenever I give the title and say plot this, first that, the first thing is the vertical axis, the second thing is the horizontal.
Okay.
axis.
So the circumference is on the x-axis?
It's circumference versus diameter.
Yeah.
So the first word in the title
Okay, so
is the
X.
vertical,
Okay, cool.
what math people call the y-axis. It's not the y-axis, it's the circumference axis. Other questions? Cake formulas. Formulae. We got the two VFs, so we have VF equals VI plus AT. And the constant acceleration kinematic equations. And then we have hopefully a marker that works on it now. Then we have the VF squared equals VI squared plus 2A dot delta X, S, whatever we happen to be using today. Let's just use S for the fun of it. Then we have the two displacement formulas, delta S equals VIT plus 1/2 AT squared. And delta S is equal to VI plus VF. As stated in one of the videos, there is a fifth equation that some textbooks give, but I tend not to use it. It looks a lot like the third one, except that it's VFT minus 1/2 AT squared instead of VIT plus 1/2 AT squared. An object. Starting with an initial velocity of negative 15 meters per second. accelerates uniformly. At, let's do 7 meters per second squared. For 10 seconds. You know what, that's 151, we're more sophisticated than that. For 11 seconds. What is the final displacement? What is final displacement? What is the final displacement? What is the final velocity? What is the average velocity? What is the at what time is the displacement negative 50 meters? At what time is the displacement positive 50 meters? What distance